Alright, this is a review over some angle relationships that we need to know for plane geometry. And so I'm looking at the first two. I want to remind you that this first one has two endpoints, so that is what you call a line segment. This one has one endpoint and goes forever in one direction, that's called a ray. Those have a special relationship because they're always the same distance apart. They're in the same plane, always the same distance apart. If they extended forever, they would never meet. Okay, that is the term parallel. And it's kind of denoted by a little, what looks like an 11 or a slanted parallel set of line segments. Okay, parallel. So that's your first word. Second word, these have a special relationship because they hit to form a right angle. That little square that they put in the corner tells you that that is a right angle, and if lines, rays, or segments meet to form right angles, they are said to be perpendicular. And that is denoted by an upside down T. So there's your symbol for parallel. There's your symbol for perpendicular. And when you have lines, rays, or segments that intersect like these, they form angles. Angles A, B, C, and D are formed by these two line segments intersecting. And we have some special relationships here that I want you to know. A has a relationship with B because they're right next door. They share a common vertex, which would be that point right there, and this common side of the angle. Okay, so they're right next door to each other. We call that adjacent. A is adjacent also to D. It shares that same common vertex, and it shares this common wall or common side. Okay. A also has a special relationship to C. Angle A and angle C are what we call vertical angles. Vertical angles are directly across from each other when lines, rays, or segments intersect. And that tells us something very specific. They are congruent. And that symbol that I just drew is a congruent sign. It's a wave above an equal sign, and what it means is they have the exact same measure. So if angle A happens to be 50 degrees, then guess what angle C is? If angle A is 50 degrees, then angle C is 50 degrees because they are congruent, because they're vertical. You might also notice that another angle is directly across from D, which is B. B and D are also said to be congruent because they are vertical angles or directly across from each other. And sometimes adjacent angles have something else special, so I'm going to go back to the adjacent angles, A and B. If you added angle A, which I'm going to highlight here in yellow, to angle B, which I'm going to highlight here in blue, you get this green angle. And this green angle is what we call a straight angle. Straight angles have a measure of 180 degrees. So I could tell you that the measure of angle A plus the measure of angle B has to equal 180 degrees. And that is a word that we call supplementary. Two special ones we want you to know. Supplementary adds up to be 180 degrees, and complementary adds up to be 90 degrees. So if I had two that added up to 90 degrees, like these two, then now I would say, well, this C and this D, the measure of angle C plus measure of angle D, adds up to a perpendicular right angle. Does that make sense? So here's a little bit of practice on that, and then I'll add one new thing at the end. What I notice here is this is a straight angle, and I have two adjacent angles, this angle and this angle, that add up to that. So those two are what we call supplementary. So I could tell you that 9x plus 3 plus 105 has to equal 180. And all of a sudden we're in an algebraic equation. So let me combine my like terms. I'm at 9x plus 108 equals 180. And then we just solve it like an algebraic equation. They did this, then this, so let me undo that. Those cancel out, and I'm left with 9x equals 72. Divide by 9, and I get x equals 8. So to make that a true statement, that x right there had to be an 8. The second one is a set of adjacent angles, but this time they don't add up to 180, they add up to 90. So that one plus that one equals 90. So I could say that 2f plus, and let me combine my like terms, that 12 and that 36. So that'd be 2f plus 48 equals 180. Now I'm in a two-step equation. This time I'll solve it with rainbow. There was an f, they multiplied by 2 and added 48 to get to 180. So we need to subtract 48 and then divide by 2. If I take 180 minus 48, then I get 32. And then I take 32 divided by 2, and I get my answer, which is f equals 16. The last example I have not gone over yet, but we need to know that every triangle has a sum of the interior angles. That means if I add this angle up, and this angle up, no matter what it looks like, doesn't matter if it's a right angle or an acute isosceles angle or an obtuse scalene angle triangle, all of these, if you add the three interior angles, you're going to add up to 180 degrees. That's just a piece of information we need to memorize. So what I see there is I have one 90-degree angle. Doesn't say the number, but I know what that symbol means. And I have a 33-degree angle. And I have an unknown angle, which I'll just call F. And if I add them all together, I get 180 because every triangle adds up to 180. So let me combine my like terms. I get 123 plus F equals 180. Solve it. They added 123, so I'm going to do the opposite. Because I'm not doing it, I'm undoing it. And I get F equals, that's a terrible 3. F equals 57. So that angle up there must be a 57-degree angle. 57-degree angle. So that's another thing for us to know. All triangles add up to 180 when you add the sum of the interior angles. So I'm going to show you some application of that. So here we have some intersecting lines. If I look at some things that I already know, I can use those pieces of information like vertical angles are congruent, supplementary angles add up to 180, and the fact that all triangles, the sum of the interior angles equals 180 degrees. I can use those to tell some more information about this. So right now, I have a little bit of information. I have that this is a 42-degree angle over here. That's angle YCG. Just remember how to do that. That's angle Y. You have to put the vertex in the middle, YCG. It has a measure of 42 degrees. Well, that tells me that the one directly opposite, its vertical angle, which is angle HCF, is 42 degrees. Has to be, because vertical angles are always congruent. I also see that this is a right angle, so if that's a right angle, its vertical angle, which would be GCK, is a right angle. That's a 90-degree angle. I can see this angle down here is a 90-degree angle, so its vertical angle has to be 90 degrees. Okay. I can also use then some supplementary pieces. For example, doesn't this 90 plus this angle PKD right here have to add up to 180? So if I take 180 minus the 90 that I know, this one has to be a 90-degree angle. And I can do that exact same thing to get angle CKF right up here to be 90 degrees. So I now know that those are all right angles down there. I can also use supplementary right up here because I know that this measure of this line is 180 and this is 42 and 90, and so I could use that to say, oh, I can figure out this little angle right here. So 90 plus 42 is 132, and if I take 180 minus that 132, I'm going to get 48 degrees. So that angle has to be a 48-degree angle. Or again, that tells me if that one's 48, its vertical angle, which would be right up here, angle ACY, has to be 48 degrees also because vertical angles are congruent. We already know this one's 90 degrees because of its vertical angle. Then I feel like I'm stuck for a minute because I don't know much about down here in this area about F. If I pay attention, this is a triangle. And I know that every triangle adds up to 180 degrees. So I have a 90-degree angle in there, and I have a 48, so that's 138. So I have to take that 180 minus 138 because I know they all add up to 180. And then I'm ready to subtract and I get 42. So guess what? That is a 42-degree angle. And if that's 42, then its vertical angle, which is angle MFW, is 42 degrees. Then I could use supplementary to get this angle right up here because this angle that I'm highlighting in black is 180 and this is 42 of it. So if I subtract from 180, I'll get that remaining angle. So 180 minus the 42 that I know gives me its supplement, which is, of course, 138 degrees. So that has to be 138 degrees. And if that's 138 degrees, directly across is its vertical angle that's 138 degrees. And we started out with a couple pieces of information, and now we know every single angle there because we know this list of small things here. I'm not going to work these out, but I'm going to show you how to get the equation that you can then work out. So what do you notice about the information? If you want to know K, you're going to have to set up the relationship that those two are vertical, and so 3k plus 30 has to equal 57 because we know those two angles are congruent. Then you'd be ready to solve it. The relationship being shown here is different, however. Those two angles add up to this straight angle, so they are supplementary. So this time I would have to say that 4m minus 2 plus 102 equals 180. Then, of course, you could combine your like terms, and you would end up with 4m plus 100 equals 80, and you'd be ready to solve them. But you have to recognize what relationship you had. The last time we had vertical angles, which are congruent. Now I have supplementary angles, which add up to 180.